Chip resistors come in several different sizes. While some of them are relatively large, the trend is to use smaller components. The last two digits represent the width of the component, that of several layers of ceramic with internal metallized layers. Because metal heats up much faster than ceramic, these ceramic capacitors need to be heated slowly to avoid internal separations between the ceramic and metal layers. This internal damage will generally not be visible, since any cracks will be inside the ceramic body of the component. In some cases, a crack may be so small that the damaged component will function properly for a while, but the heating and cooling caused by turning the product on and off will cause the component to expand and contract. This may eventually cause the separation to grow to the point where the component will fail. This is why we need to avoid rapid heating of ceramic chip capacitors during the soldering operation. Ceramic chip capacitors will require gradual heating methods, which we will explain later in this tape. Another style of chip component has a molded chisel tips, are basically shaped like a chisel. The flat section of the tip has a lot of surface area, which helps to transfer the heat quickly. Conical tips also resemble their name. Conical tips also come in extremely small sizes for micro-miniature applications. Bifurcated or forked tips are also useful for chip component rework. Forked tips come in several sizes to accommodate many of the different styles and sizes of chip components. The size and shape of the tip will also have a significant effect on the rate of heat transfer. Larger tips with more surface area will transfer heat much faster than smaller tips. Tip selection will be based on the size of the component. While there is no exact rule about how the size of a single-point tip should compare to the size of the termination, it's obvious that if the tip extends too far beyond the edge of the joint, it could come in contact with another component or the surface of the board. The lands while both joints are still molten. Perhaps the reason that this method is ever used is that it doesn't require any special tools. There are some major disadvantages with this technique. For example, as the component is pushed away from the lands, it can lodge against another component. As the molten solder solidifies, the component will be resoldered to the other component. This type of removal operation can also leave a stream of solder on the board. Depending on where this solder ends up, it can create additional problems. The amount of heat needed to keep both solder joints melted simultaneously can also weaken the adhesion of the land onto the surface of the board. If the iron starts to push on one side of the component as the opposite solder joint begins to solidify, the pressure can cause the land to separate from the circuit board. Some technicians use two soldering irons to remove chip components. This technique can overcome some of the problems we just mentioned, but it does. The ends of the fork tip fit over the component with just a slight amount of extra space for solder. Learning which components fit into specific tips takes experience. Before we begin the tip preparation process, tip cleaning procedure, since the wire will scratch all the way down to the base metal. This would allow oxidation to form on the base metal and severely decrease the useful life of the tip. After cleaning the tip, since the tip has more metal surface area than the lands on the circuit board, the solder will be drawn toward the metal tip, and so will the component. Fork tips can be used to remove a number of different styles of chip components, as long as they fit properly in the cavity. At this, we need the solder to be soft or ductile in order to absorb the stress of expansion and contraction caused by the heating and cooling of the circuitry. That's why it's best to remove all of the old solder from the lands and replace it with fresh solder whenever a component is reattached. There are two techniques for preparing surface mount lands, depending on the type of equipment you have available. The first method uses a solder removal braid. Solder braid comes in different widths. We'll want to use one that matches the width of the land or is just slightly smaller. After we place, You'll need to practice with each of the different tips to see which one you prefer for different situations.